Hey everyone, this is Kalyan Kumar and once again welcome you to this videos that we have on IUPAC Nomenclature of Organic Compounds. And today we have the Nomenclature of Aromatic Compounds. Now aromatic compounds, as I'm sure you're aware, are compounds in which we have either a benzene ring or any other aromatic ring or a benzene type of ring. So let's get started. Let's try and see what we have here. We have a benzene ring and this is attached to something. Now there are various possibilities of what can be attached here. So we're going to explore each of those possibilities in this particular video and try to figure out how we name those. And that is what we have categorized this thing as aromatic compounds. So aromatic compounds are the compounds in which we have benzene type of rings and they are attached to either functional groups or side chains, and we're going to see all those possibilities. So let's get the ball rolling with the first rule, which says that the aromatic compounds are cyclic compounds which contain one or more benzene type of rings. Benzene being the simplest hydrocarbon of the aromatic series. It has a planar cyclic ring of 6 carbon atoms, as I've already shown, and it has 3 double bonds in alternate positions. Okay, so now let's look at various situations. Various situations of a benzene ring attached with various types of groups. The first is what happens when a functional group is directly attached to a benzene ring. Functional group attached directly to a benzene ring. So let's assume that you have a benzene ring and you have a functional group attached here. Something like this. Or perhaps NH2. Or perhaps a CHO. Now, how would you name these? Well, the naming depends upon the nature of the functional group that you have. For example, how would you name this one without a benzene ring? Suppose I have a cyclohexane ring. You call it cyclohexanol. Okay? Now, the moment you have a benzene ring, things become different. Because here, what happens is that these compounds are named as derivatives of benzene. That means benzene is the parent and these are the derivatives on it. So if the functional group is directly attached to the benzene ring, then they are named as derivatives of benzene. For example, look at this one. Now this would be hydroxy benzene. Remember, it's a benzene derivative. It has to end with benzene generally. Not always, but generally it has to end with benzene, especially if this can be called as a substituent. So it is hydroxy benzene. You can also call it phenol, which is the common name accepted in IUPAC. What would you call this one? Remember, all ethers are named as substituents. So what would you call this substituent as? It's methoxy. So it's methoxy benzene. It's also known as anisole, and that is the common name accepted in IUPAC. But what would you call this? Now remember, we never called this as a substituent. So we will call it benzene carbaldehyde. Just like any other cyclic aldehyde, this is benzene carbaldehyde, also known as benzaldehyde, and that is the common name accepted. What would you call this one? Well, it's a ketone, and this is going to be the parent. It's ethanone, and we call it phenylethanone. So this is phenylethanone, also known as acetophenone. That's the common name accepted in IUPAC. Let's get some more. What would you call this one? Remember cyclic carboxylic acids? This is benzene carboxylic acid, also known as benzoic acid. Okay. Next one, try this. And remember, nitro is always a substituent. It's a nitrobenzene. What do you call this one? What kind of a compound is it? Can you see it's an ester? Ester of which acid? Benzene carboxylic acid. So we can either call it methyl benzene carboxylate or methyl benzoate, because we can also call the acid as benzoic acid. What kind of a compound is this? Can you see it's an anhydride? You have a C double bond O, then an O, then another C double bond O, and a CH3. How do you name anhydrides? Alkanoic anhydride. So one of them is benzoic, ethanoic anhydride. So this is benzoic ethanoic anhydride. What would you call this one? It's benzene carbonyl chloride. Try naming this one. Remember what you call this as? Carboxamide. So it's benzene carboxamide. What would you call this one? Remember cyclic nitriles? Benzene carbonitrile. What would you call this one? Benzene amine. Remove the last E. Benzanamine or aniline. Now, in case you have more than one substitution, then you can write the numbers 1, 2, or you can write ortho. 1, 3, you can write meta. 1, 4, you can write para. So the position of the substituents in a disubstituted benzenes are indicated either by prefixes such as ortho for 1, 2, meta for 1, 3, and para for 1, 4. However, many of their common names have also been adopted in the IUPAC system. Let's check out some of them. Look at this one. What would you call this? Which is the principal functional group? It's OH, right? It's a derivative of phenol. So, it is numbered as 1, 2, what would you call it? 2-nitrophenol or orthonitrophenol. And what would you call this one? This is going to be a sitter. This is 3-nitrophenol or metanitrophenol. And what would you call this one? Simple, 4-nitrophenol or paranitrophenol. Try this one. It's benzoic acid. So it's 2-methyl benzoic acid or orthomethyl benzoic acid. What would you call this one? Now, this is going to be interesting. Remember, it's benzene carbonitrile And the chloro is the substituent, position number 4, 4-chlorobenzene carbonitrile or para-chlorobenzene carbonitrile. So this is the situation when the functional group is directly attached to the benzene ring. What happens if the functional group is attached to the side chain, not directly attached? Then in those situations, the benzene ring is named as a phenyl derivative. If the functional group is present in the side chain of the benzene ring, then these are usually named as phenyl derivatives of the corresponding aliphatic compounds. Alright, so what would you name this one? Can you see it's acetic acid? And it also has a phenyl group here. So it's phenyl acetic acid or phenyl ethanoic acid to be more precise. What would you call this one? Same logic applies. But here you got to number it, remember. So this is number 1, this is number 2, this is number 3. It's 3-phenyl propanoic acid. Now what happens if hydrocarbons are attached to the benzene ring? That means if you have a benzene ring having only hydrocarbons attached to it. So aromatic hydrocarbons containing one ring. So in such a case, they are again derivatives of benzene. These are called arenes. These compounds are called arenes. So aromatic hydrocarbons which contain both aliphatic and aromatic units are called arenes. And they are named as alkyl benzene. Aromatic alkanes are named as alkyl benzene, that is provided the compound attached to the benzene ring is saturated. That means if this is the benzene ring, I have a saturated system, no double bond or triple bond here. In that case, it is known as alkyl benzene. Try naming this one. It's 1,2-dimethylbenzene, common name xylene, orthoxylene. What would you call this one? Same logic. 1,3-dimethylbenzene or metaxylene. And following the same logic, paraxylene or 1,4-dimethylbenzene. Now try naming this one. Guess what would be this one? It is isopropylbenzene or cumene. Try naming this one. So how would you number this? That's the key here. How would you number this? Now, what you need to understand here is that this carbon gets position number 1. And this carbon gets position number 2, 3, 4. You're going to start like that because remember, they are derivatives of benzene. Benzene is the parent and the one attached to the parent is number 1. This is a side chain, alkyl benzene, remember. So this is a side chain. Side chain is always numbered by considering the carbon attached to the parent as number 1. So number it. What would you call it? Well, it's 1, 2, 3 trimethylbutylbenzene. And what happens if there are double bonds or triple bonds attached on the side chain? Then the benzene becomes a phenyl group. It becomes a substituent. Aromatic alkenes and alkynes are named as phenylalkene or phenylalkyne. Try this one. This is phenylethene, also known as styrene. Try this one. Number it first. And obviously double bond gets the preference. 3-phenyl propionine or 1-propene, whichever way you want to call it, also known as allyl benzene. What would you call this one? Well, numbered 1-phenyl propyne or 1-phenyl propionine or 1-propyne, whichever way you want to call it. And finally, in this particular section, let me give you something a little complicated. Yeah, this is going to take a while. So pause the video, name it. Look for the longest carbon chain containing maximum number of multiple bonds and number it so that the double bonds or the multiple bonds get the lowest number. And as you can see, I got 1 double bond here, 1 triple here, 2, 3. And if this is 3, if I go this way, again 3. So I think I'll have to go this way because it has maximum number of carbon atoms then. So numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10. So 10 is the maximum. So what are the substituents we have? We have methylidine. We have allyl. And we have phenyl. And a lot of methyls there. So it's 7 allyl, 10 methyl, 4 methylidine, 10 phenyl, undeca, 2,7-diene, 5-ine. And the last section, when you have more than one benzene ring attached, that means fused rings. So aromatic hydrocarbons containing more than one ring. Now their names are different. The parent names are different. Aromatic hydrocarbons containing 2 or more fused rings have different parent names. For example, this fellow, the parent name is naphthalene. This fellow, parent name is anthracene. Try this guy. Oh, the name has appeared first. Phenanthrene. This is called phenanthrene. Now, when hydrocarbon chains or functional groups are present on these rings, the compounds are named just like they would be named in the case of benzene. So the only difference is wherever you have benzene, you got these names now. And when these become substituents, the naphthalene becomes naphthalene. Remove this particular E and put YL. I don't know how you pronounce this. Remove this E and put YL, naphthalenyl. Same here, same here. So if they are going to act as substituents, this is the way you name them. Naphthalenyl, anthracenyl, phenanthrenyl. Wow, pretty mouthful there. And lastly, you got to number these rings also, and their numbers are fixed. They have to be numbered in a particular way. Naphthalene is numbered like this. When these rings are numbered, the pattern of numbering is fixed. Look at naphthalene. Naphthalene ring. 1, 2, 3, 4, 5, 6, 7, 8. We don't number those two bridge carbons. Anthracene. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Phenanthrene. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the numberings are fixed. So whenever you have to give a name to a group that is attached in these positions, this is the way the numbering is done. Obviously, try and give the lowest number possible. So this is a brief video on how we deal with the naming of aromatic compounds, and I hope this video helps you in understanding that. And if you have any doubts, anything that you want to talk about, drop into the comment section below. Thank you for watching the video.